Hello, I'm Elias Mhozi. I work with a team that uses technology, mostly 3D printing, to make education, most especially STEM education, equally accessible to the learners with visual impairment or blindness. Let my colleague Cynthia tell you more about what we do.
Uganda is a wonderful country. With 77% of its population under 25, it's also the youngest population in the world. The difficult reality, however, is that this young and promising population now faces the most difficult education access problems, especially ones with disability. 14% of the 10 million children in primary and secondary have some form of disability or impairment. The commonest form of disability is visual impairment. Sustainable Development Goal 4 states to ensure inclusive and equitable quality education and promote lifelong learning opportunities for all. For children with visual impairment, access to inclusive and equitable quality education is difficult. Even when they get to school, they require not so common tools to function in school. First, they need to learn Braille, a system of writing and reading by touch. This is their only gateway to grammar, punctuation, numeracy, and everything else. In Uganda, Braille writing tools have to be imported. The deterring cost of this import sometimes means children should learn in shifts or worse, go home. A slate and a stylus, for example, cost $20. That's 50 times the amount required for a pencil and an exercise book. Other essential tools include numeric cubes and slates, abaci or abacuses. In addition to this challenge, STEM subjects are better elaborated during teaching and learning with the help of diagrams and images. Visually impaired learners are unable to access these diagrams and images for learning purposes. In secondary school, STEM subjects are excluded entirely from their learning schedule, and learners are only encouraged to explore to the extent of their ability. We harness the power of 3D modeling and printing to make these tools at far cheaper rates to equip every blind child with the important tools they need for the strongest start possible in school. Learners with visual impairment and teachers help us not only identify but also analyze the essential learning tools and pictorial representations of various STEM concepts. With this information, we formulate a pathway for a solution. The solution involves a process of how to design or replicate and produce materials that meet the problem deduced from the assessment. Designing and computer-aided design modeling are done to obtain three-dimensional models. 3D printing is done to produce physical models, mostly in PLA or biodegradable plastics. The models are then taken to schools for review and feedback from teachers and learners, or for use if ready.
Then you can open and read for him. What have you written?
The styler here. Use both hands.
Can you read what you wrote?
Bees, egg, vegetable, honey.
Honey, yes. Those four, eh? Can you spell the word honey?
Honey.
Very good.
What about this one on top?
On top, the first line. Read
Read what
the
you
first
written
line.
up.
Be very class.
First line.
Ni
Page oil.
Genesis.
All of our Genesis.
We have so far designed and produced a stylus which, from our visits to Guru Primary School, we were told that it is actually better than what they were already using. We have designed and produced an abacus which, compared to what exists in the market, it's easier to use, mostly for the lower level learners.
Only.
Huh?
Very good. The second line. T stands for.
Dad.
Good. Third line.
H.
H stands for.
Here is a braille learning board from one of the teachers at Guru Primary School. We learned that it is mostly used for the beginners in learning braille language. And we made this optimized not only for efficiency, but also reduced cost of production. Here is a human heart model, one of those models that we make to represent science concepts that would otherwise be represented by diagrammatic representations that are inaccessible by the blind.
Hey, my name is Basil, and then I'm visually impaired myself, and through my entire education, I probably knew the heart exists and the parts, but I couldn't even imagine like the shape of the heart and how the parts are connected until this little model was printed. And then you have the pulmonary artery here and how it branches off to the lungs. Everything is really good. I mean, I think if you are looking for an experience which is closest to visual processing of images, then I think tactile representation with accurate details like this probably provides the best experience of science and math pictures. So this is really great.
We look forward to and hope to enhance our capacity so that we can make various learning tools more affordable and easily accessible to as many learners with visual impairment and blindness as possible.